Welcome to this video on neural networks. We will cover neurons or perceptrons, activation functions, cost function, backpropagation, and gradient descent. Neurons, or perceptrons, are crucial for transmitting signals in the brain. Artificial neural networks, or ANNs, are software approaches based on natural biological systems to replicate biological neurons. Biological neurons consist of dendrites, a cell body with a nucleus, an axon, and axon terminals, all involved in signal transmission. Artificial neurons receive inputs, X, with associated weights, W. The processing element calculates the sum, applies a bias, and uses a transfer function to produce outputs, Y. The perceptron mathematical model calculates the output f of x by summing the product of inputs and weights and adding a bias. Multiple perceptron networks are structured with an input layer, one or more hidden layers, and an output layer. Activation functions are primarily used to calculate and decide the output of a neuron. Types include step, sigmoid, hyperbolic tangent, and rectified linear unit, or ReLU. The step function, a simple activation function, outputs 0 if x is less than 0, and 1 if x is greater than or equal to 0. The sigmoid function is a smooth, S-shaped curve often used to introduce non-linearity into the network, scaling the output between 0 and 1. The hyperbolic tangent function, or tan, is similar to sigmoid but outputs values between -1 and 1. The rectified linear unit, or ReLU function, outputs x if x is positive and 0 otherwise. This makes it computationally efficient. The cost function calculates the difference between actual values, y, and predicted values, a, determining the network's error. A drawback of the basic cost function is that it can slow down learning, leading to the use of cross-entropy. Cross-entropy is an alternative cost function that reduces the cost and accelerates the learning process of the neural network. Gradient descent is an optimization algorithm that finds the minimum value of a function to minimize cost. It iteratively adjusts weights from a random initial value towards the minimum. Backpropagation is essentially a revision of weights. In a feed-forward network, weights are changed until the least cost function or error is achieved.